With Mrs. Milburn, you already have learned about the sine function and its graph. Very much like it was the graph of the cosine function. Both of them had, for their domain, all real numbers. You could put in any angle you wanted. The range, the y values, only came out to -1 up through +1. They're both periodic functions, the fundamental period of 360, and they both had an amplitude of 1. So now we're ready to tackle the graph of the tangent function, and it won't look anything like the other two. Trying to remember here some of our basic functions. Basic values. The tangent for 0 degrees would be the sine of 0 divided by the cosine of 0, or the y over the x. And that, as you remember, was 0. The tangent for 30 degrees would be sine value is 1/2 divided by the square root of 3 over 2. That came out to be the square root of 3 over 3. But when we plot it on the graph, that's going to be about 0.58. 45 degrees, the sine and the cosine are the same, so the tangent value is 1. 60 degrees, the sine's square root of 3 over 2, the cosine's 1/2, so the tangent's the square root of 3, which is about 1.73. 90 degrees, the sine of 90 was 1 and the cosine was 0, so at 90 it was undefined. So maybe we could try, 80 degrees. Put an 80-degree angle in here. This is not one that you would have memorized, of course. And its tangent value is about 5.67. So I'll try to plot some of these. 0, 0. Let's see if I can divide this up reasonably evenly. At 30 degrees, it was 0.58. 45 degrees is right in the middle here. It was 1. 60 degrees, it's about 1.75. 80 degrees, it's about 5.67. 89.9 degrees, which I didn't put on the chart, but that's close to 90 degrees. The tangent value is actually 572.96, approximately. In other words, this thing is going off the chart here. Way off the chart. At 90 degrees, the tangent value does not exist. This is going to be one of those good old vertical asymptotes. We can go around the circle in the other direction. Try -30. Well, -30 is going to have the same sine and cosine values as +30, except one of them is negative. So that would put it at -0.58. And 45 degrees, the sine and cosine values are the same, except that the sine value is negative. So that's going to be at -1. And for 60 degrees, it's going to be 1.73, except it's going to be negative. I got that a little off track there, but that's okay. And it's going to be a very similar graph, except it's going to be headed in the negative direction. And at -90, down here, the sine is -1, divided by the cosine is 0. So once again, it's undefined. we are going to have another vertical asymptote. Going around the circle at 180 degrees or negative 180 degrees. Oops, sorry. The sine value is 0 divided by the cosine is negative 1. So at 180 degrees, the tangent value is going to be 0 divided by negative 1. And the graph is going to be a repeat, because at 270 degrees, the sine value is negative 1 divided by the cosine value is 0. We've got another horizontal asymptote at 270. And we're going to have another one at 450. So the tangent graph is totally wild, way different than sine or cosine. So the tangent graph here has some issues. Negative 90, positive 90, 270, 450, all those are asymptotes and there's no tangent value, which means that's going to affect our domain and range. I'm going to look at a more professional example of the graph. And they labeled in terms of pi, in terms of radians. That's okay. We can do it with degrees just as well. Of course, they expect us to be able to do both. So, because the tangent is undefined at these asymptotes, that means we can't use those values as part of our domain. Unlike the sine and cosine, we can't put in every single angle. And if it does follow a pattern, we got it's undefined at negative 90, at positive 90, at positive 270, at positive 450, and so on. So that's going to affect our domain. The domain is the set of inputs, and the inputs are the angles we're putting in. We can do it in either degrees or in radians, and I'm going to choose to do it in degrees. It's going to be all real numbers. We can put in any angle we want, any number, as long as it's not one of these asymptotic values. So not equal to 90 plus, and you notice from negative 90 through 0 up to positive 90, that's 180 degrees. From 90 degrees to 270, that's 180 degrees. Likewise, from 270 to 450, that's 180 degrees. So it's going to be plus or minus, sorry, not equal to 90 degrees plus or minus n times 180, where n is an integer. So it could be 90 plus 3 times 180. It could be 90 minus 2 times 180. Any one of those values would give us another asymptote. This could be written in terms of pi over 2 plus or minus n times pi. Okay, the range. The range are the results, the y values of the function, basically, the f of x values. How high does it go? How low does it go? Unlike sine and cosine, which bottomed out at -1 and topped out at +1, the range for the tangent function is infinite. All real numbers. Now the sine and cosine functions were periodic, And oddly enough, so is the tangent function. This is a periodic function. But its fundamental period is not a whole trip around the circle like it is for sine and cosine. Fundamental period goes from negative 90 to 90, goes again from 90 to 270. So the fundamental period here, it takes 180 degrees, or pi, not 2 pi. Every 180 degrees or every pi radians, the pattern repeats. Amplitude. For the sine and cosine graphs, the amplitude was 1. Goes one space above its center, one space below its center. Well, if we take the maximum y minus the minimum y and divide by 2, that's going to be infinity minus negative infinity divided by 2. So that would be 2 times infinity divided by 2, which is infinity. We don't really have an amplitude here. No number, no numerical amplitude. So the tangent graph is indeed a pretty unique beast. Pretty wonderful. Please notice that the tangent is 0 at many different points. The tangent of 0 degrees is 0. The tangent of 180 degrees is 0. The tangent of negative 180 degrees is 0. Likewise, the tangent value of having a tangent value of 1, that works for 45 degrees. Tangent value of 1 is going to work for 225 degrees. Tangent value of 1 is going to work for 405 degrees. There are many different angles that have the same tangent value. That's going to also be true for sine and cosine, and we'll have to worry about that when we work with which we're going to do in just a moment. It would help if you were able to print out a sheet that says lesson 6.8, simple inverse trig practice. That's what we're going to work on next.